All right. Good evening, everyone. Thanks for sticking around. So my name's Ciaran Conliffe. I work for Liberty IT. We're an IT company based here in Belfast and down in Dublin. We're owned by Liberty Mutual. I've been working in software development for about 20 years now. And for the last half of that, I've been working in that sort of grey area between development and security. So DevSecOps, application security, and secure development has been a lot of my focus. Now, secure development I would define as teaching developers how to code securely, which is a tricky business. Some of it's about skills. Most of it's about mentality. Most of it's about getting people into that sort of constructive paranoia state that makes for good security. And I find that threat modeling is a really great way to get that sort of threat-focused thinking into design, into construction, into all the phases of creating software. Threat modeling was also really useful for us because we used to have a real problem like years and years and years ago where the development team spoke one language and the security team effectively spoke a different language. So you'd have a meeting and you'd spend about like half an hour just getting up to speed on what each of you were talking about. And threat modeling is a great way of loading security knowledge into the developers so that they're able to talk intelligently to security people, which is good. So, as I mentioned, like I've been threat modeling for 7 or 8 years. We've been doing it as a company for about that long, and we've got a lot of experience in it. We've hit a lot of pitfalls. We've learned a lot of things along the way, and I would like to share those all with you here today. I really would, but there is a problem. Hands up anyone here who signed an NDA. Yeah, for those of you who haven't, the first time you sign an NDA, this is about what it feels like. It's kind of a terrifying prospect. But the thing is, like, for very good and sensible reasons, I can't actually show you any of the threat models that we've worked on over the last 8 years because, well, actually, this is a general problem in security discourse in general. A general problem in general, great. But the issue is that it's easy to talk about attacks. It's fairly easy to talk about active defense. But talking about passive defense is not something that we can do that easily because you worry about compromising your defenses. And it's this whole big gap in the experience that people are sharing and the things they're talking about. You don't get these real life lessons communicated well. But I have a solution. I'm just going to tell you some stories. In fact, what I'm going to do is I'm going to give you some fictional contexts for the real life lessons learned. So I'm going to talk about 4 companies, 4 places, 4 scenarios for threat modeling that aren't like anything I've ever worked on. Now, they may bear some relation to some real life things, but you can figure that out for yourself. But what I'm going to talk about is a smart home heating system. I'm going to talk about a smart car. I'm going to talk about a Bitcoin exchange. And I'm going to talk about a hospital. And we're going to see what real life lessons we can apply to threat modeling these types of things. So let's start with the BURROW smart home heating system, the best fictional home heating system on the market. The next time you want to heat your fictional home, get a BURROW. Actually, quick check. Who here has done threat modeling? Okay, most of you. So I don't need to get too much into the basics, but for the benefit of the rest of you is like the basic idea of threat modeling is very simple. You just model out your system, reach a common understanding, then go through it and say like, okay, where can we find threats? The gold standard for it is the STRIDE methodology that was developed at Microsoft, which they put out about 15 years ago out into the world for people to use. And that's what a lot of people base it on. And this is the exact type of threat model that you would see people doing based off that. Is you've got your external entities, your processes, your data stores, and you just map out the flow of the data through it. This is like really good. And like actually the first big lesson I'll give you is like don't have your threat modeling session and have someone turn up with this diagram already drawn. The real value in modeling the whole thing is getting people together to model it, so they had a common understanding. But it is a great way to sort of like get people thinking in the same space and to communicate. But it's not great for communicating things out. Because the thing with this is, like a diagram like this, the people in the room talking through it may have an idea of what's going on inside this microservices server or inside the app and all. But if you're putting this to someone who has no idea, then it's not great for communicating it. And part of the thing with this is that this isn't really a classic data flow diagram. As I said, this is the way everyone draws their threat model diagrams in the Stride methodology, or people often do, but they're not really using processes, because a microservices server isn't a process, it's a component. So we would talk about this as a component-based data flow diagram, as opposed to a process-based data flow diagram, where you actually do out your processes and you explain, so like, okay, this is how the data is actually being manipulated. And you use boundaries to mark out your components. Now, this was kind of a paradigm shift for us in threat modeling, because it did help us to get a lot better understanding of what we were looking at. And it also meant that your threat model suddenly becomes a great vehicle for explaining your system. If you've got things mapped out like this, your threat model is a lot more accessible to people who aren't working on it. So the second part of the Stride methodology is applying your threats to it. And you can see in this case, like this is your smart home heating system. You have your preferences that list when you're going to be at home, when you're not going to be at home. And that's obviously an information disclosure thing. You've got your mobile app connecting to your microservices server, and there's spoofing there. The thing to it, though, is that you could just as easily have found those if you'd used the original diagram. So that's and if all you want to do is drive out the threats, then the original type of diagram is a perfectly reasonable way of doing it. So it's the whole thing, like there isn't really a wrong way to do them. The whole point is just to drive it together and get the common understanding. So let's say that you have, like you've we've done your threat modeling. We've created our BURROW smart home heating system. I've told you about how great it is. You've gone out and bought one and installed it and straight away, and it's going fantastic. Then one fine morning in June, in the middle of the biggest heat wave that Belfast has ever seen, you wake up with your heat on full blast. You go downstairs and your cat is staring like this at your thermostat. You go to see what he's looking at, and this is what greets you. What's happened is that Poison Pill Update has stuck ransomware on your thermostat. It's playing a high-pitched sound that only your cat can hear, which is why he's currently destroying your sofa. And your heating's burning up and you're roasting, and it's not a good situation. But the thing is, like, what's happened here? Why didn't we catch that in our threat modeling? Well, the answer here is so that we had our people in the room doing the threat modeling. We had all these process design people, and they were going like, yeah, here's what we're designing in there. But we didn't have any of the people who were actually working on the device in there. So we missed out on the fact that inside the control unit, your code is being pulled from firmware. And the firmware is another data store that you need to consider. And the lesson here is really like, make sure you have all the relevant expertise involved in your threat modeling session, because it's very easy to have people who are focused on one area of your design and it gives them a tunnel blindness into it. So that's the BURROW home heating system. Next up, a bit livelier, is the Greenhorn Iroquois smart car. Now, you might ask, like, why would you threat model a smart car? But I mean, modern cars are really just mobile phones with 2 tons of metal and an engine attached to them when you get down to it. This is using the same sort of like standard DFD component-based notation, but this is the standard architecture of a car. Where you have a controller area network in the middle, all the things hook into it, messages get passed around. Fun thing with this is, like, this is actually the architecture that cars have had since around the 70s. which is one thing to bear in mind with all this Internet of Things stuff, is people act like all these devices only came into existence when they started plugging the internet into them, but your architectures have evolved from the original versions of those devices. But this also points out the issue with, because in this case, like if we're looking at a car, what we're really doing is we're threat modeling the architecture of the car. So if we started trying to use this data flow diagram notation, we'd just be redrawing the architecture diagram. So why don't we just use the architecture diagram? And this is a perfectly valid, this is actually a real smart car architecture system. This is the automotive service bus, which was developed by the University of Munich and open sourced. It's kind of cool, and we'll get into some of the features of it in a second. But the thing here is that if what you're threat modeling is your architecture, if what you're threat modeling is something you already have a diagram for, then it makes perfect sense to just take your diagram and start adding your trust boundaries or adding your machine boundaries to it rather than redrawing the whole thing in with less information. So I mentioned that, so this was developed by the University of Munich, as I said, and they were thinking about security when they designed it, which is something that becomes clear when you start adding the trust boundaries to it. You can see that what they've done is rather than one single controller area network, they've set 3 separate ones, and they've isolated them from each other. So the idea being that if someone compromises the entertainment system, they don't automatically have control of the car's transmission and be able to turn off the power to your wheels when you're doing 70 down the motorway, because that wouldn't be good. So that's what they've done there. But there's also some interesting things that come out when you start drawing this on, like that iPad that's sitting inside a machine boundary. Now, that's actually the control console for the car. In this design, you control the car through an iPad that's mounted in the dashboard, and it has a Wi-Fi connection to the architecture to talk to everything, which is obviously a little bit of a security concern that pops out once you start adding these boundaries in. And we can pretty easily add in our threats and say, like, okay, yeah, there's a spoofing and elevation of privilege on the API there. There's a denial of service threat, I guess, on the all the bits of the transmission. You can see there's this sort of like side connection through the into the battery area that might lead to the denial of service on the battery stuff. And you can get some value out of this, but we are falling into a big trap here, which is that I mentioned Stride earlier. We're using Stride to look at the threats for this. Stride, again, it was developed by Microsoft. It's a really great way of classifying the threats to an IT system. The problem is that we're not threat modeling an IT system. We're threat modeling a car. And cars have very different attackers and very different threats to worry about. This is, again, from the University of Munich. This is from a white paper that 2 of their professors and a guy from the German University of Applied Science did. But this is breaking down the potential threat actors on a car. And you can see that there's some very different people involved here than you would think about in terms of an IT system. Like, I like the tuner one, which is like someone who owns the car and thinks, well, I own it, I should be able to do whatever I like to it, which includes opening big gaping security holes in it. But I'm going to focus in on the thief, because the thief in this case, we normally think of thieves in terms of IT systems, in terms of wanting to steal information, financial information, credit cards, personal info, that sort of thing. But this is someone with a different goal. And the best way to get from that goal to actual threats to us is attack trees. Well, in this case, it's more of an attack beanpole for simplicity's sake, but this lets us start with our attacker, work through what do they want to do, or what are the things they might want to do, how could they do it, and then how could they attack our system to do it. And based off this, we can add a new theft threat to our model, and we can see that, oh yeah, these 2 driver door and passenger door modules might also be something that someone might want to attack. So we have to protect those accordingly. So again, it's the whole thing, it's like you have to consider what you're threat modeling as well as the actual threats that might be on it. So Next, the Mt. Fox Bitcoin exchange. This comes from an alternative universe where Mt. Fox was the name of a Fox-themed MMO that went bust, and then the website got repurposed by its owner as one of the first big Bitcoin exchanges. And but because it's an alternate universe, the people doing that really cared about security, so they decided to start threat modeling it as they were building it. And if we start doing a component-based data flow diagram in this, you can see that you hit the problem immediately, which is that it's way too simple. You don't have a lot of moving parts in terms of components here. You just have your transaction engine that hooks into things, and then your user client that goes into that. So you can't really get the many good threats out of that. On the other hand, if you start doing a process-based data flow diagram, it balloons out of control very quickly because you've got loads of processes going on here, because trading exchanges are very complicated. Like, just take, for example, selling. You might want to sell right now. You might want to sell when a value reaches a certain threshold. You might want to sell at a specified time. There's all different kinds of use cases for it. And that points to a way that we could drive out threats on this and model it, which is not using data flow diagrams at all, but using misuse cases. Now, that's not necessarily that readable because it's a little bit small, but basically this is a fairly standard use case for someone wanting to sell their Bitcoin immediately. So you have your different actors in there, which is your person who wants to sell it. There's they ask, can we sell it? It goes out to their wallet and we check, do they have enough? Okay, then we take it out, transfer it to our wallet, transfer payments over to their bank, and simple. Where the misuse side of it comes in is when we start adding in new actors to the use case. People who might want to do bad things, such as a thief. Now, in this case, the thief might want to intercept the transfer of the Bitcoin and redirect it into their wallet rather than our wallet. Or they might want to steal the person's payment credentials as they're transmitted to the bank. There's other actors we could add in then, like we could add a fraudster in who wants to sell a load of Bitcoin and then immediately force the price to drop and then immediately buy back all the Bitcoin at a lower price, which is a problem that did plague a lot of early transaction engines because they didn't think it would happen. So we go through all these. And this is good because like we're actually thinking about security right when we're designing out our processes. And we build in all this security and we put it out there, and then something good and bad happens, which is that unexpectedly we're hugely successful. Everyone's talking about Mt. Fox. It's on the front page of the Financial Times, so like the ultimate Bitcoin trading thing, and we're like everyone's looking at us, which unfortunately means we have to start acting like a real company now, which so, for example, we did our threat modeling, we listed out all our threats, and we put in place solutions for them, which is good. Like, we've solved all our problems. But we have to convince these guys that we have done that. This is the logo for the European Court of Auditors, by the way, and it's just such a great logo, I thought I had to get it in somewhere. But it's, how do we prove that we've implemented our mitigations? Well, same way we prove everything in engineering. We use tests. I'm a huge fan of adding tests to threat models in general because it keeps people honest and it shows that they've actually put their mitigations in place. But if you need to be able to prove out your threat model and prove that you've met the needs of it, then having tests in place means that the auditors can go through, they can check your test data, they can rerun the test themselves if they want, and it's a provable artifact now. So, last story is about St. Vidicon's General Hospital. I think hospitals are the next big thing in InfoSec. And it's a really broad subject. I'm not going to get too into it. Edwin mentioned I Am the Cavalry earlier, and they have a lot of really good stuff about this out there. Basically, there's a lot of security vulnerabilities in hospitals and medical systems in general. There's not a huge amount of impetus on people to secure them so far. I think you get the first big GDPR adjacent medical information breach, and all of a sudden there'll be a lot of money pouring into this, and there's a lot of companies already starting to position themselves in it. So this is a broad thing, and I'm just going to look at a very simple system in there. We're going to look at the system for the nurses to manage patient records on the ward. So this is like just a simple system. Nurse on the ward wants to check the status of a patient and then record new information. Okay, blood pressure this, temperature that. Very simple. Except that the information in question is medical information, and medical information is privacy kryptonite. It's radioactive. You have to be very careful with it. You have to make sure it's managed properly. And so we can't just have people being able to go in and access it. We need to put in place an authentication mechanism. We need to check that these nurses are allowed to access these particular patients' records. And this is an example of how you should really iterate over your threat models, because you do your first threat model, it feeds back into your design, hey, you need these additional pieces. Then you iterate back to your threat model and say, okay, let's add in these extra pieces and see what new things pop out. So we do that a few times, and eventually we come up with a system where we've got, okay, the administrator, the matron on the ward assigns out which nurses can access which patient records, and the nurses log in and they can see the patients. And on paper, it all looks great. And then 2 weeks down the line, we look at the logs and we notice after the deployment, and we notice, hey, none of these nurses have ever logged in. The only person who's ever logged in is the admin. And she's logged in all day. What's going on? The answer is that we've designed a system that's great on paper. In practice, nurses are out there saving people's lives, running around. They're heavily overworked. They do not have time to be constantly logging into a system and logging out of it. So what they've done is they've just logged in with the admin role that can access all these records, and just left it sitting there all day, which is a sign that we've fallen into the trap of we've designed a system that we think people should be using as opposed to something that actually matches their needs. So the solution is obviously replace the login step with something like tap your badge in an RFID reader and it unlocks the computer, and then we're happy because we can read this is this specific nurse and they can access these records. The nurses are happy because all they have to do is tap and it unlocks, and it's great. So, but again, it's just you need to build a system that people will actually use and not that they're driven to circumvent. So the last lesson, the last pitfall that we've fallen into is a mistake that we've made on every single diagram that I've drawn for you so far, including this one, which is that we haven't included our logs. And this is you have to make sure to remember that as well as all the things you're designing and putting out there, there's all these non-functional requirements sitting out there. There's logs, there's backup systems, there's all these additional data stores that you need to worry about, especially with personal info, and go in and audit them and have tests for them and so on. So there's a bunch of stuff there summing up the general lessons learned, but to me, the main thing to bear in mind is that threat modeling shouldn't be something that you're doing in isolation. Threat modeling is something that you should be integrating into your processes, integrating into your thinking about, okay, what are we actually doing and what are we actually trying to accomplish, as opposed to just having it as an exercise that people go through and is rubber stamped and it's done at the end. So, but that is me. That is my Twitter and Liberty IT's Twitter and LinkedIn and Facebook and all that sort of stuff. I do not tweet about InfoSec much at all, but if you like ranting about historical things, then that's where you'd find that. But that is me. Anyone have any questions?
Anybody have any questions? No questions at all? Sure? All right. Thank you very much. Awesome presentation.